All right, so in this video, we're going to introduce basic dimensional analysis. And dimensional analysis is a way to convert from one unit to another. It's sometimes called unit analysis or unit factor method. It's very important in chemistry and physics and many other disciplines. And the key terminology we're going to use is the vocabulary term a conversion formula. And a conversion factor needs to be distinguished from that. Here are some examples. The first conversion factor I'll discuss is that of feet to inches. And of course, we're familiar with that conversion formula, 1 foot equals 12 inches, but there are two different conversion factors that we can write. One is 1 foot over 12 inches, and the other is 12 inches over 1 foot. The most important idea here is that both of those conversion factors are really equal to 1. For instance, what's 5 over 5? 5 over 5 is 1. What's 12 over 12? 12 over 12 is 1. What's 1 over 12? That's not 1, that's 1/12. But 1 foot over 12 inches, that's a whole different story. That's really equal to 1 because 1 foot and 12 inches are equivalent. I can do this for any conversion formula. Any conversion formula can be written as two different conversion factors. It really just depends which one's on top, which one's on bottom. And it turns out that these are useful for different things. This can be used to convert from inches to feet, whereas this can be used to convert from feet to inches. Next, notice that this example shows that the conversion formula does not necessarily need to have the number 1 in it. I could say how many psi are in 1 kilopascal or vice versa, but we can also just say that these two quantities are equal. Including units in the conversion factor is, of course, important, like it says here, because 1/12 is not 1, but this is. And so we're always going to want to include units when we're writing out a conversion factor. Of course, anything multiplied by 1 is itself. In other words, if you multiply by 1, the quantity retains its identity. So what if I took a measurement like 75 inches and I multiplied it by this very special type of 1 foot over 12 inches? You can see that this measurement, 75 inches, is really not going to be altered at all. It's just been converted into new units. And the way I'd think about that is 75 inches multiplied by 1 foot divided by 12 inches. And of course, that's 75 divided by 12, which is 6.25. But it's also inch feet divided by inches is just feet. So we're typically going to write that in this simplified form here, where you see the dimensional analysis problem shown. Units are canceled. That's a dimensional analysis problem. That's what we're going to learn to do here. So let's turn the page over and look at some other examples. It's helpful to note that there's always going to be more than one way to write a conversion factor, or at least I should say two different conversion factors for every conversion formula. And while the one we just looked at can be used to convert from inches to feet, it would not be able to convert from feet to inches. We'd need its reciprocal to do that. The unit cancellation should always be shown in the problem so that we can see that what's being canceled works out and gives us the units that we want to be left with. So the steps we're always going to follow are written out here. And then we'll do a couple of practice problems. First of all, write down the measurement or quantity you want to convert from. So for instance, 16,500 joules to calories, we'd start by writing down what we'll call the given units, or the known quantity. And then we're going to write the conversion factor so that the given units are on the bottom and the desired units are on the top. Put that conversion factor in parentheses and make sure that that quantity is equal to 1. Then do the math operation, make sure the units cancel, and you are left with the desired units. Make sure that when you're writing your final answer, you include the correct units. And we also want to talk about significant figures here. And in just a moment, talk about how many significant figures it's appropriate to include in the answer. Now, we'll start by using this first example, and we'll show how that problem will be set up. If I want to convert from 36 inches to centimeters, the first thing I want to do is write down the quantity that I'm going to start with, and that would be 36 inches. And then I'm going to put just an empty set of conversion factor here, or an empty set of parentheses. The units I want to get rid of are inches, and the units I want to end up with are centimeters. If I set it up like this, then you can see inches will cancel. And the conversion formula, which is written here, I'm going to copy into this conversion factor so that the units stay with the numbers they're associated with. It's not 1 over 2.54 because it's 2.54 centimeters in 1 inch, not the other way around. And now I can see that this is going to be a matter of multiplying these two numbers. And that's how I'm going to get my answer. 36 multiplied by 2.54 is 91.44. Let's talk about significant figures. This measurement has two significant figures. This number has 3, and of course that only has 1, but this conversion factor is not a measured number. This conversion factor is a precise number. That's the definition of a centimeter inch conversion is 2.54. There's no more significant figures missing there. So it's not a measured number, and it doesn't affect our significant figures considerations. In other words, I want to round this to 2 significant figures, and that means I'm going to say this is 91 centimeters. 2 significant figures matches the 2 significant figures that I started with. Now, when you're doing these calculations, sometimes you're going to see that we end up with a multiplication because this is essentially the mathematics that's going on here. A times B over C is AB over C. And if the letter C is a 1, then of course this simplifies to AB. But there are other examples where the letter B is the 1, and that's going to simplify to A over C. So dimensional analysis ultimately helps us determine whether the conversion is a matter of multiplying two numbers or dividing two numbers. We'll look at a few more examples in class and practice this a little bit more before we begin discussing some more advanced dimensional analysis on the next page. So take a look at some of the other practice problems here. We'll solve those in class and see if we can agree on those answers.